Imagine standing at the edge of the Southern Ocean, watching as a solitary figure trudges away from the breaking waves, away from the screaming colony, away from everything evolution has programmed into its bones for millions of years. The sun hangs low and cold. The ice stretches endlessly. And this penguin, this single, determined creature's walking straight toward oblivion. You might call it poetry. Scientists call it a mystery wrapped in catastrophe, because while the sight of a lone penguin marching toward the interior of Antarctica feels like the opening frame of an art film, the biological reality is something far more chilling. This is not a metaphor. This is a complete system failure in one of the most sophisticated survival machines nature has ever built. Penguins do not wander. They navigate. They coordinate. They survive by being part of something greater than themselves. So when one breaks away and walks into the wide abyss, what you are witnessing is not rebellion or curiosity. It is the collapse of everything that keeps them alive. Picture the Antarctic continent not as a landmass but as a vertical universe of hostility. The coldest air temperature ever recorded on Earth was measured here. -128.6 degrees Fahrenheit. The wind does not blow, it carves. The ice does not rest, it consumes. For a penguin, the interior is not merely inhospitable. It is biologically impossible. There is no food, no water, no shelter. Just an endless cathedral of frozen silence where even the concept of survival becomes absurd, and yet, they walk. Let me take you inside the body of a penguin to show you just how extraordinary this breakdown truly is. Penguins are not just birds that happen to live in cold places. They are biological fortresses engineered over tens of millions of years to thrive in one of the most extreme environments on the planet. Their feathers are not feathers in the way you understand them. They are overlapping scales of insulation, up to 100 per square inch, layered so densely that water cannot penetrate and heat cannot escape. Beneath that, a thick layer of blubber acts as both fuel reserve and thermal barrier. Their circulatory system is a marvel of countercurrent heat exchange, where warm arterial blood preheats the cold venous blood returning from their flippers, ensuring that core temperatures stay stable even when standing on ice for weeks. Their social structure is equally vital. Penguin colonies are not random gatherings. They are living algorithms of survival. In the brutal Antarctic winter, emperor penguins form what scientists call a hydala, constantly rotating mass of bodies where individuals cycle from the freezing outer edge to the warm interior and back again. This is not cooperation in the human sense. It is thermodynamic necessity. Alone, a penguin dies in hours. Together, they endure months of darkness in conditions that would kill most mammals in minutes. So when a penguin abandons the colony and walks inland, it is not just leaving behind companionship. It is severing the biological contract that keeps it alive. Now, let me introduce you to the theories. The 7 possible explanations for why this nightmare scenario unfolds. These are not guesses. They are windows into the fragile architecture of a mind under siege. Theory 1. Psychological short-circuiting. You have to understand something about stress. In humans, we know that extreme trauma can fracture the psyche, leading to dissociation, repetitive behaviors, catatonia. We have language for it. PTSD, psychotic breaks, nervous collapse. For penguins, we lack the vocabulary, but the mechanism may be disturbingly similar. Imagine a penguin that has survived a leopard seal attack. The water erupts in violent teeth like daggers, jaws that can shake a 40-pound bird like a rag doll. Most penguins die. Some escape with injuries, but a rare few survive intact, physically. Yet something in the brain has been rewired by terror. The neural pathways that once guided it toward food, toward the colony, toward survival, are now firing in chaotic loops. Scientists avoid the word insanity when discussing animals. But what else do you call behavior that is systematically self-destructive? The penguin begins to walk. Not in search of anything, not fleeing a specific threat. Just walking. The motor cortex is active. The legs move. But the decision-making centers that should be saying, stop, turn around, return to safety, are simply not responding. This is not a choice. This is a machine running a program that no longer correlates with reality. Researchers who study animal behavior have documented similar breakdowns in other species subjected to prolonged stress. Captive elephants that rock endlessly, parrots that pluck themselves bald, dolphins that refuse to surface for air. In each case, the behavior is maladaptive, serving no survival function, driven by something deeper and darker than instinct. For a penguin, the walk inland may be the behavioral equivalent of a system crash. The ancient drive to move, to migrate, to hunt, to explore remains active. But the compass that should direct that movement has shattered. What you are witnessing is motion without meaning. A body betrayed by its own mind. Theory 2. Senile decadence. Age is a predator that hunts in silence. In the human world, we understand dementia as the slow unraveling of memory and cognition. Names vanish. Faces become strangers. The present dissolves into fragments of a past that may or may not have existed. For penguins, the endpoint is the same, even if the terminology is different. Older penguins, those who have survived a decade or more in the Antarctic gauntlet, begin to show signs of neurological decay. Their movements become less precise. Their responses to environmental cues lag or fail entirely. The brain structures responsible for spatial memory and navigation begin to deteriorate, much like the hippocampal atrophy seen in aging humans. Now imagine being that penguin. You have spent your entire life locked into a rhythm: breed on the ice, hunt in the ocean, return to the colony, repeat. The colony is not a place you choose to visit. It is a magnetic north written into your neurology. But now, in the twilight of your life, that internal map is fading. You look around and nothing seems familiar. The cacophony of calls from thousands of penguins no longer resolves into individual voices. The ice, which once told you exactly where you were, now looks identical in every direction, so you walk. Not toward anything, just away from the confusion. And because the interior of the continent is vast and empty, there is nothing to stop you. No barriers, no cues. Just an infinite expanse that swallows you whole. Researchers studying seabirds have documented cases of elderly individuals becoming separated from flocks and wandering into areas where they have no survival prospects. This is not suicide in any intentional sense. It is the biological equivalent of getting lost in your own neighborhood and being unable to find your way home. Except here, getting lost means death. Theory 3. Navigational malfunction. Penguins navigate using a suite of sensory tools that would make a military-grade GPS envious. They used the position of the sun to calculate direction. They sense the Earth's magnetic field through microscopic particles of magnetite in their brains, essentially carrying a built-in compass. During long oceanic journeys, they integrate these cues with visual landmarks, ocean currents, and even the angle of polarized light filtering through the water. But what happens when the compass breaks? Imagine a software glitch, except it occurs inside the brain. A mutation, a minor stroke, an infection that inflames the neural tissue responsible for magnetic sensing. Suddenly, the internal map is rotated 180 degrees. What should register as north now feels like south. The ocean, which should be a comforting presence to the north, now seems like it lies to the south, and the interior, the deadly frozen heart of the continent, now pulls with the irresistible certainty that this is the correct direction. This is not theoretical. Scientists have documented magnetic disorientation in migratory birds exposed to artificial electromagnetic fields. Homing pigeons fitted with magnets lose their ability to return home. Sea turtles, which also rely on magnetic cues, can be tricked into swimming in the wrong direction if the local magnetic field is altered. For a penguin, the result would be catastrophic. Every instinct says move towards safety, but the internal compass now defines safety as the interior. The bird walks with absolute conviction, never doubting, because doubt requires recognizing that something is wrong, and the brain, locked into its faulty map, cannot process that error. You would walk confidently into your own death, and you would never understand why the world stopped making sense. Theory 4. Parasitic infection. Now we enter the realm of biological horror. Parasites are not passive passengers. They are puppet masters, and their host is the stage. Consider Toxoplasma gondii, a single-celled parasite that infects rodents and rewires their fear response. Normally, a mouse smells cat urine and flees. But a mouse infected with Toxoplasma is drawn to the scent, practically offering itself to the predator. Why? Because the parasite needs to get inside a cat to complete its life cycle. The mouse is just a vehicle, and the parasite has hijacked the steering wheel. In penguins, there are parasites and pathogens that target the central nervous system. Avian influenza, bacterial infections, protozoan invaders. Some cause direct tissue damage, inflammation, lesions, hemorrhaging. Others are more subtle, altering neurotransmitter levels, disrupting the flow of information between brain regions, scrambling the signals that dictate behavior. A penguin infected with such a pathogen might lose its social instinct entirely. The colony, which should feel like home, now registers as threat or noise. The ocean, normally a source of food and safety, becomes avert, and the open ice, empty and silent, feels neutral, perhaps even preferable. The penguin walks, not because it wants to, but because the infection has rewritten the rules. Its body is no longer fully its own. The virus or parasite is optimizing for its own survival, not the host. And if that means sending the penguin into the wasteland, so be it. There are documented cases of seabirds infected with neurotropic viruses, exhibiting erratic flight patterns, crash landings, and complete loss of navigational ability. In terrestrial birds, West Nile virus causes disorientation and circling behavior before death. The mechanism is the same. An invader disrupts the brain, and behavior collapses into chaos. Theory 5. Acoustic interference. Sound is not just noise. For animals that rely on acoustic cues, it is information, navigation, survival. Penguins use vocalizations to locate mates and chicks. Within the deafening roar of a colony of 100,000 birds, they listen to the ocean, the ice, the wind. They have evolved in a world of natural soundscapes that carry meaning. Now imagine introducing something alien. The deep, resonant hum of a research vessel. The seismic blasts from oil exploration, sending shockwaves through the ice and ocean. The low-frequency pulses of military sonar, powerful enough to cause hemorrhaging in the ears of whales. These sounds do not just annoy, they interfere. They overload. They scramble the auditory processing centers of the brain, turning meaningful signals into incomprehensible static. A penguin exposed to such interference might lose the ability to process directional cues. The calls of the colony, which should guide it home, now sound distorted or come from the wrong direction. The subtle acoustic signatures of open water versus solid ice become indistinguishable. In this sensory fog, the penguin makes a guess, picks a direction, and walks. There is evidence for this in marine mammals. Whales beach themselves in areas with high naval activity. Dolphins strand in the aftermath of underwater explosions. The exact mechanism is debated, but the correlation is undeniable. Disrupt the soundscape, and animals lose their way. For a penguin, the effect could be even more insidious. Unlike whales, which can surface and reorient visually, penguins on land rely heavily on integrating multiple sensory streams. If one stream is corrupted, the entire system can fail. Theory 6. Genetic anomalies. Evolution is not a designer. It is a blind watchmaker, building organisms through trial and error, preserving what works and discarding what fails. But occasionally, the process produces a misfire, a mutation that slips through because it is rare, or because it does not manifest until after the organism has reproduced. Imagine a penguin born with a defective gene that regulates social bonding. In most species, there are specific neurochemical pathways, oxytocin, vasopressin, dopamine, that make social contact rewarding. Isolation feels bad. Proximity to kin feels good. This is not philosophy. This is neurobiology. But if the gene that codes for oxytocin receptors is mutated, the reward signal never fires. The colony does not feel like safety or community. It feels like nothing. Or worse, it feels like stress, crowding, noise. For this penguin, Walking away from the group is not irrational. It is the only thing that makes sense. Similarly, consider a mutation affecting the fear response. Normally, the sight of vast empty ice triggers caution. It screams danger. But if the amygdala of the brain structure that processes fear is underactive, that signal is muted. The penguin walks into the interior not despite the danger, but because it does not register danger at all. These genetic anomalies are vanishingly rare, which is why you do not see mass exoduces of penguins into the wasteland. But rare is not the same as impossible. And in a population of millions, even a 1 in a million event happens. Theory 7. Extreme nutritional stress, starvation, is not just hunger. It is a cascade of biological failure. The body begins to consume itself, breaking down muscle for fuel, then organs, then finally, critical structures in the brain. Cognitive function deteriorates. Decision-making becomes impaired. Hallucinations can occur. In humans, we call it starvation psychosis. For penguins, the process is similar. During breeding season, male emperor penguins fast for up to 120 days while incubating eggs. Their body weight can drop by 50%. They survive on stored fat, but there is a limit. If food becomes scarce, if the sea ice extends too far, if fish populations collapse, if a storm prevents foraging for too long, the penguin enters a state of metabolic crisis. At this point, the brain is running on fumes. Glucose levels plummet. Neural activity becomes erratic. And the drive to find food, normally a focused and adaptive behavior, becomes decoupled from reality. The penguin begins to search, not in the ocean where food exists, but in whatever direction it happens to be facing. Logic fails. Spatial reasoning collapses. The bird walks into the interior because the starvation-damaged brain can no longer distinguish between productive foraging and suicidal wandering. There are documented cases of starving animals exhibiting bizarre maladaptive behaviors. Deer walking into traffic, birds flying into windows repeatedly, bears wandering into towns despite their natural wariness of humans. In each case, the underlying cause is the same: a brain deprived of the nutrients it needs to function correctly. So when you see that penguin walking toward the center of Antarctica, understand that this is not a simple story. This is the intersection of 7 catastrophic possibilities, each one a window into how finely tuned, how fragile, the machinery of life truly is. This is a creature built by evolution to endure the unendurable, equipped with navigation systems that rival our technology, social structures that allow survival in conditions that would kill most life on Earth within minutes. And yet, a single malfunction, a parasite, a mutation, a moment of overwhelming stress can send it walking into the void. The Antarctic interior is patient. It does not chase, it simply waits. And when a penguin arrives, exhausted, disoriented, its internal compass shattered, the ice does what it has always done. It takes. There is something deeply unsettling about this image, something that cuts through the science and touches on something primal. Because we understand, on some level, that we are not so different. We too rely on systems neurological, social, technological that we barely comprehend. And we too are vulnerable to the same kinds of failures. A chemical imbalance, a moment of trauma, a slow fade into confusion. The penguin walks because something inside it has broken, and in that brokenness, we see a reflection of our own fragility. But here is the thing that researchers often overlook in the rush to explain the anomaly. The vast majority of penguins never walk into the interior. They live, they breed, they survive. For every one that breaks away, there are hundreds of thousands that remain integrated into the colony, following the ancient rhythms that have sustained their species for millions of years. This is not a story about the failure of evolution. It is a reminder of the statistical brutality of life. In any system complex enough to function in extreme environments, there will be outliers, failures, glitches. The miracle is not that some penguins walk into the void. The miracle is that most of them do not. And when we watch that solitary figure trudging across the ice, silhouetted against the pale Antarctic sky, we are witnessing something that is simultaneously tragic and instructive. This is what happens when the invisible architecture of survival collapses. This is the edge case, the failure mode, the moment when biology reveals its limits. The penguin does not know it is doomed. It walks with the same determination it would use to reach the ocean, to find its mate, to feed its chick. The body is doing what bodies do, moving, persisting, trying. But the map is wrong. The compass is broken, and the destination is death. In the end, the ice will claim it. There will be no funeral, no marker, no record beyond perhaps a fleeting observation by a researcher or a grainy piece of footage that circulates on the internet. Confusing and disturbing viewers who cannot reconcile the image of a penguin with a landscape it was never meant to inhabit. And perhaps that is the most haunting part. This is not a story about penguins adapting to new environments or expanding their range. This is a story about what happens when the systems fail. When the navigational compass spins wildly. When the brain, that magnificent organ that has guided countless generations to survival, misfires and sends its owner marching toward oblivion. The long walk is not a choice, it is a catastrophe in slow motion, a biological tragedy playing out on the most unforgiving stage on Earth. And while we may never know which of the 7 theories explains any individual case, what we do know is this: in the struggle for survival in the Antarctic, there is no room for error. One wrong turn, and you are walking into forever.